All right, we're back here with part 2 now, continuing on with limits. Okay, we're going to look at some more examples. And here we have a function, and we have, as you see, a vertical asymptote going through at 2. So let's make up a limit question. Let's say the limit as x is approaching 2 of this function. Okay, so if we look at this function, we know that if we come on this side, the left side is going to positive infinity, and if we approach on the right side, it's going down. So they're splitting. So this does not exist. So let's break it into parts, one-sided parts. So let's say the limit as x is approaching 2 from the right side. Okay, what do you think the answer would be? Well, the right side over here, you can see as x is going towards 2, where's the y value? It's going to negative infinity. And if we say the limit as x is approaching 2 from the left side, so we're going left side, where is that x value going? To positive infinity. So these do not equal. Okay, let's look at the same example here, and let's look at some other limit questions. Let's say the limit as x is approaching negative infinity. Okay, so I'm going out here to negative infinity, way out there, towards negative infinity. Where's the y value going? Well, you can see it's flattening out here, so it's probably going to be the asymptote right there at 0. So the answer would be 0. So let's say we have a limit as x is approaching positive infinity of this function. So now we're going way out this way. And you can see that's going up and up and up and up, so it's going to be positive infinity. Now let's look at the one below here. So let's make a limit question. So the limit as x is approaching infinity. Okay, f of x. Well, if you can see that this is going straight out here off to positive infinity, this line is flattening out, so it's got a horizontal asymptote of 1. If we do the limit as x is approaching negative infinity, so we're going this way, it's flattening out at 0. So a note here, just for your information, that when we have limits as x is approaching positive or negative infinity, you're going to have horizontal asymptotes. Okay, so just remember that. Probably it's flattening out. All right, so I have an exercise for you guys to do, and you guys can pause the video and then do these questions, and I'll put the answers up and see how you did. Okay, so this is a point. So watch out, that's a point. Same as this guy, it's a point. Same as this guy, it's a point. So when f is 0, so we know it's 2. As x is approaching 0, hopefully you got 2. At the point negative 2, this is a tricky one, so watch out, because this is the answer right up here. It's the point, because this is a hole. So the answer for this guy is going to be 5. As it's approaching that, that's right here. So that is going to be 1, because you're on the function. Positive 2, you should have does not exist, because one is going up, the other one's going down, and the point of 4, this is the black one, so you put 1, and what is the limit as you are approaching 4? Hopefully you put does not exist, because it's jumping. See, it's jumping. They're not equal. The left side and the right side are not equal. Okay, so this little exercise, looking at a table of values, just pause it and see what you get for limits. So hopefully, when you did the first one, you put does not exist, because here is positive 1, here's negative 1. So they're not equal. These guys are not equal. What does this mean? Undefined. That means you probably have a vertical asymptote. Okay, so it's jumping there. All right, for the next question down below, we're approaching 1. Again, this is a point, so don't be distracted. That's just the point. You know, that's just the point where the function comes this way and you have that, it comes this way. So that's just the point. So here's what we're looking for, these numbers. So it's approaching 4. Now we're going to look into evaluating limits. So we have limits that are, we have a value like 2, 5, -2, and we have ones that are infinity. So just remember, these guys generally have horizontal asymptotes. Well, the general rule in when you're evaluating these guys is I call it the plug and chug substitution. Okay. Sometimes you can't do it, so then there's a set of rules that we can do. Some little tricks: L'Hopital, factoring, conjugate, complex fractions, and use substitution. So let's look at some examples here. Okay, so let's try the first one here. So we have a function, and we have a limit at x is 3. So we're plugging and chugging. So we're going 3, and the 3 goes into there, -1. So we get 9 minus 1. So the answer is 8. So we would say, as the limit approaches 3 of this function, 3x minus 1, the answer, the limit, is 8. It's approaching 8. All right, so let's try the next one. So plug and chug. So we have the square root of 4 squared minus 1 squared. Well, we know a square root and a square cancel. And we know 4 take away 1 is 3, and then we have it squared. So the answer is 9. So I'll read this for you. Okay, the limit as x is approaching the square root of 4, or we could say 2, of this function, the limit is 9. Okay, so let's, you guys pause and try that one, and I'll put the answer on. So hopefully you got 3. Okay, now we're going to look at some one-sided limits. All right, and one-sided limits are, I'll draw a graph for you so you can sort of visualize it a little bit better, and then we'll put it into context. So I'm just going to put a graph here. Let's make an x and y axis. Okay, so let's graph. I'll do this guy in blue. So I am going to make it very, very light because I'm going to cut it off where it's supposed to be cut off. So when f of x equals x, so when I'm graphing f of x, remember it's y equals x. So we have the y-intercept is 0 and over 1 up 1. And we basically, it's going to do a little dotted line here just because it's going to be cutting off here. Now, I'm going to do the other one green. So when y equals negative x plus 3. So 1, 2, 3, and down 1 over 1. Down 1 over 1. Down 1 over 1. So this function looks like, again, I'm just going to do a dot because now I'm going to make it solid because we have some restrictions to it. So let's put it into context now because we have, this only exists when it's less than 1. Okay, so here's 1 right here. That's where 1 is. Okay. This is where 2 is. 3. This is where 4 is. Okay. So now we know that this guy, the blue one, exists and it's including, so I have to put a dot, it's including, and it's only less than, so it's only this part. And the other function, the green one, it exists when it is greater than, but not including. See, it's not including. So it's got a circle, and it's going this way. All right, so that's what it looks like. Now, if we look at the limit question visually, we can see it's jumping. So the answer is does not exist. Okay? You can visually see it. Now, if we don't want to draw it and just plug and chug, this is what we do. Well, you're taking this guy, this 1, and plugging into there. So we have 1, and then we put it into there, and we have 2. So they do not equal. So plug and chug, you can see that the x1, and this is the minus x plus 3, 1, they don't equal.